Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to talk about fiber to home. So let's dive right into it. The first thing you have to understand, we have a very old network. Now this network of phone, telephone line and all that, it is a basically upgraded network of telegram network. So it's not a very, forethought and knowledge and all that was put into it. So foundation of this technology is very ancient. Basically it's just having one cable to directly where you want to talk. So you will have two cable going to your pole will have like 10-20 wire coming to it, then a big bundle wire will go to a distribution box. That distribution will have multiple big wire coming to, and even a thicker wire that will go from distribution box to something like this in your telephone exchange, and then it goes to wherever it has to go. So this architecture is ludicrously limiting and we have already maxed it out. Basically, even though advent of modern electronics and modern switching signals, we tried creating ADSL. Basically on this itself we started to sending dual signal. Basically you can have voice independent and data independent, so you can buy something like the splitter and split out the data and basically voice calls. So it did work, but we have already maxed it out. At this point in time you cannot expect even 100 Mbps out of this. Some places they do try to push that much, but you cannot. So we have already maxed it out. It's done, like it's done. However, today our data needs have grown exponentially. We went from like when I was a little kid, full HD video was like whoa. Now we have 4K, 8K cameras are already out. So at this point in time we are consuming data at alarming rate. So we need something better, and transmission range is a very critical factor with this. That's why many rural places simply don't have telephone network. So because of this complexity, you really can't transmit this very far, because if you directly take a cable and stretch it to a very long distance, the voltage drop would be so high that signal simply won't reach. So even few kilometers is not practically achievable. You have to have repeater, boosters and all that, and it's too complex and prone to interference. So whenever lightning strikes happen or lightning storms happen or something like big electrical faults happen, these are very susceptible. And I'm not talking having electrical faults in it. An electrical fault near it can create a magnetic field that can disrupt this, and it is very common. So people are referring, hey, I'm getting this nagging sound, I'm getting the interference and all that. I had landline for like till few years ago. I had landline, and this was common issue. Like sometimes water seeped into the main cable and it's like it didn't sound well. So all those interference is very problematic and it's very complex. Like look at it, it's just frustratingly complex. So you have to understand this one crucial aspect. So once we had like big telephone exchange, they were connecting using optical fiber very early on, as early as 1980s. Now if we have used fiber for connecting these places that early on, why didn't we use fiber to connect our home? Problem was, at that point in time we simply haven't invented cheap basically optical amplifiers. So in the very early days, basically when the foundation of optical was being laid down, what we used to have is like optical link. Okay, optical link was like lossless for 10 kilometer. What do you do after 10 kilometer? So they had a power station. They will collect power, they will take the optical signal, convert that optical signal into basically digital signal, and that digital signal would be again converted into optical signal. So basically you will take the optical, convert it into electrical, then reboost it and then send it away. Now this happens, this was very fast, very efficient, but it was still added 2 to 3 milliseconds of lag. Now you have to understand, this was happening every 10 kilometer or every 100 kilometer. Undersea cables are as long as like 1000 or 5000 kilometers. So understand it, at that point in time you are adding way too much latency, and light speed is not at light speed while it's traveling under an optical fiber. It's traveling slower. So it's first out flat out, it's traveling slower. On top of that you are adding lag, and the lag may not sound that much, like okay 2 millisecond or 5 millisecond, it's not that much, but when you have multiple of those, that can translate to upwards of half second lag. So that issue was solved by introduction of what we classify as optical amplifier. Basically what we did, we had optical line coming into it, put it into a laser. If you are familiar with laser, you must know like laser is just light amplification by stimulated emission of radiation. That stimulation became the data signal. So whatever was coming into the optical fiber, that was triggering the laser. Basically laser was not doing anything. Laser was like, I am in prepared state, I am ready to be excited. So laser is there, and it's like the moment on pulse came, like basically 1, it boosted the signal. When it went to 0, basically no pulse was coming, it was not doing anything. So that way we can boost signals at light speed or whatever was traveling in the fiber without slowing it down, without converting it. This transformed the basically foundation of our telecommunication. This is the sole reason we have all the communication of our planet going through undersea fiber cables, because once we have created this, we can make very long fiber cable. We can make like whole transition would be like literally at light speed. So at this point in time, this became practical, and now these things you can buy at eBay. It's very cheap. So this was like first major innovation that actually allowed us to use that. Then we come to single mode fiber. Now if you have to understand about fiber, you only have to understand two things. There is one fat fiber and there is thin fiber. Thin fiber is called as single mode fiber, basically something smaller than 9 micrometer, and then you have fat fiber, which is like 50 micrometer and 65 micrometer. Now here's the counterintuitive part. The slimmer the fiber, basically the thinner it is, the better it is. So 9 millimeter is the smallest we can properly manufacture. We have tried even thinner, but we cannot manufacture it reliably enough. So this is what the small one is called a single mode of transmission. Now what does that mean? Basically light will not bounce back. It will literally go directly, because you have to fire laser at it. So basically the electronic equipment is different. On these puppy, basically 62 micrometer and 50 micrometer, you can use LEDs, but when you're talking about single mode, you have to use lasers, otherwise the signal won't even go into it. So it has a very what we call narrow receiving cone. Basically it can't receive data from lot angle, but whatever it does receive travels very far. Like this can the fat fibers can easily do 50 to 100 kilometer. This can do 1000 kilometer. So you have to understand that this also became cheap. Earlier days there was no discussion. The cost difference between these two was 4 times. Nowadays the Geo fiber that is giving fiber to home in all over the India, that's relying on single mode. The sole reason is now cheap enough. Now of course it's still not cheaper than fat ones, but it's cheap enough. So once we have optical booster that allows the lag-free transition, we got higher quality optical fiber. Then we have introduction of splicing machines. Basically optical fibers, the biggest hurdle is that you can't handle it. It's very fragile and very problematic to bind. Basically you cannot have how we have copper cable. We have to take 2 copper cable, tie it up, put a solder joint, done. Now that's not feasible with optical fiber. You cannot do that. So what we have to do is basically first we cleave it. Basically you unsheath it. The yellow cable that you are familiar with seeing with optical fiber, they are just a casing. You unsheath it. Then you have protecting layer. Then you keep slicing it. Once you get the optical fiber, then you have to cleave it. Cleaving it simply means breaking it into exactly 90 degrees. Basically the joints must be like this. It cannot be like this, like this, like this, like this, or like this. It must be 90 degree. So a special tool is used. Now it's not that expensive, but you can understand it's a very special tool with very sharp blade that slices very quickly. It's just like exact 90 degree cut. Now once you take that 90 degree cut, it's put into this machine. This machine cost as much as a car. In early days this was so expensive, only few labs used to have that. So what you will do, it will take 2 of those fiber. You have to clean it with isobar. No dust and debris can be interfered in the process, or it will destroy the cable permanently. So once you take that, there are 2 mechanisms, basically 2 magnetic clamp. You clamp it down and it has motors. Feedback from a microscope. There is an actual I told you these are too small to see. So there is a microscope. Microscope will see it and align it in 3 dimensions, because this is way too tiny. So once it aligns it, then it pushes it closer and then electrically arc welds it. So that's how we achieve basically optical fiber nowadays. So you have to have this ludicrously complex machine plus a very skilled engineer who can utilize cleavers properly, and then you can basically connect optical fiber. So this is the reason why optical fibers were not like everybody was using it. So this machine was a limiting factor. So all these 3 things. Now the final edition of the technology is optical splitters. So we had optical boosters which can directly boost the signal, but we had no way. Basically if you wanted to give connection to a basically employee, you had to only use P2P, basically from your optic switching hub or basically your telephone exchange to the person. So what we do now is basically we have one optical fiber and we can split the data. Basically something like this. You have one input and it can be into multiple output. So generally how it's done is nowadays is basically you have one input and one output will be there. That will be continue on. So you will daisy chain it and you will get like 4, 2, 16, however you need. You will get the output from there directly at light speed. So you will not, this does not require power. This is also a very interesting part. So this allowed ability to daisy chain very long chain. So you will have a chain, let's say you had the capability, because of course this also causes signal degradation and loss, but it's like within manageable. So one optical link can easily have like 50 or 60 links coming off of it. So basically now you can have much efficient use of optical fiber. This machine allows you to now make very good cleaving cuts now. The fiber is also now much higher quality. Optical booster is there, so even if you are daisy chaining very large amount of it, and as long as bandwidth is not maxed out, let's say you want to give 100 Mbps to everyone, you must have enough bandwidth in the basically main fiber to do that. But once you have that, you can reboost the signal using this. So all these things, all these four things combined actually made fiber to home possible. Without these four things, optical fiber was just a dream for home. Then we come to the topology aspect. Okay, this technology was basically achieved early as in 2009, 2010. The foundation was laid down. Then the problem came topology. Now topology is very problematic because any ISP and all ISP, they want to make profit. They have to do it. Otherwise, like if you're talking about taking a giant loan, you don't want to just take the loan and pay the interest. Then what's the point? You want to make profit or not. So to make the profit, you want to optimize your basically resources. That's the problem. There is topology, but those topology come at consequence. So once you can have cheap topology, which is very easy, but you can have fast topology, which is very expensive. Now again, if you say somebody is like, okay, I'm getting fiber connection and they can only get like, let's say 10 Mbps, what's the point? So you have to understand, they had to balance these two things out, whether they give speed, security, reliability to someone, or they take care of the investment, the capital investment. And if the capital investment is too high, they simply won't do it. So this created a paradox, how to handle it. Now the old structure was very simple, P2P. You will have exchange. Now this was generally done for big offices, big banks, and sometimes ATMs, or especially a big shopping mall which had multiple ATMs. Sometimes they had their own direct dedicated optical link. So the optical link was like from machine to the exchange. Now this is very well and good and it does work, but the problem is way too expensive for home users. So this architecture, even though if you are very rich enough, you can do that, but Joe Rogan I think did that. But other than that, flat out most people can't afford this. So this method was created, bus architecture. The bus architecture is very simple. You will take one, daisy chain it using splitters. So you can take one cable and just lay it down, lay it underground. This is what Google Fiber was trying to do. And using splitters, you can split it out and give as many people as there. And once the signal has degraded, hopefully you would have already exhausted the capacity. Ideally, you don't want to use boosters. But if let's say for very long distance, you have to use boosters, boosters were achievable, like it was not too expensive. Then this architecture is also mixed with some architecture where you have ring architecture. Now ring architecture can be done in multiple ways. One of the ways is basically you will have two nodes. So this is I think what Jio is doing, not right now, but they will do that. Like this is the target. So you will have two nodes on the other end and you will send data through both of them. Now here's the deal, if any of the cable is cut, the data will be rerouted. So this way you have a bit of redundancy. In bus system you have one line of failure. The moment that link fails, everything goes. In P2P, again, if P2P is very redundant because telephone exchange is not going to go down. It has backup on top of backup and some extra backup, and also security, so nobody else can accidentally do anything, and people around there are like quite smart and capable. So when we are talking about opticals, you have to understand this. This was a very limiting factor. That's why I say all the technology around it has to develop to a point where we can actually feasibly, economically give you the optical connection to your home. So even though all the problems have been solved in terms of technology, why the heck everywhere you don't have optical? Like especially in America, rural America is really bad. Britain is really bad, and Britain is like such a bad case. Basically there is a lot of legal issue. You have to understand, even if let's say you are a guy like, okay, I want to start my ISP, I want to give my internet everywhere and all that, it's much easier to get a license for space rocket than it is to get for ISP. It's very difficult, frustrating, and even if let's say you are an already company who have already taken care of that, you used to provide DSL connection, all that, awesome. Now you have to plant poles or dig trenches and do all that for fiber. It's such a big issue that, and a lot of corruption is also there. So you have to grease the hand and all that, pay some extra under the table. Those things are very frustrating. Many companies flat out stopped trying, like after the legal issues became a big deal. And this was a very prominent problem with United Kingdom, UK. They really wanted like, if I'm not mistaken, they tried in 1990s fiber to home, because at that time fiber was already done as a backbone and they knew electronics were growing, and that time they were actually very rich. So they wanted to do that, and a company tried to do that, but government stopped it, thinking that if a company successfully does that, they will become too powerful. Now because they stopped it, nobody else tried it, because it's like, okay, if they tried it and you stopped it, why will I try it? You're gonna stop it, and this is government, you can't do anything about it. And this was before Japan was getting their final optical connection. This was before Italy. So Italy and Japan both ended up fiber directly to home. Britain still has very rudimentary one. So this is the legal issue, you have to think about it. So even though you may have an ISP that's like, hey, I want to give you good service and I want to take money from you, and you are like, okay, that's totally acceptable. Government is like, no. So legal issue is the issue. Cost of the hardware. Now telephone hardwares are very expensive. When you are talking about optical hardware, it's like hold my beer. Even though optical boosters are very cheap, but you have to understand, some places you have to convert that optical signal into rerouted signal. That rerouted signal has to go to the server and all that. Those puppies are expensive. And wherever you are combining, basically you are taking multiple optical fiber, let's say you have multiple areas and you are combining them into one giant fiber connection to, let's say, the server or gateway, that's also expensive. All these things combined takes a very huge amount of capital cost. You have to be like willing to take a very large risk, and any bank loan you will take for something like this will be very high interest rate. So this was also an issue. Like this was like people made hesitant. Like people like, and this whenever somebody is not having early adopters, this creates a paradox. If you don't have early adopters, you don't have the technology, flat out. The sole reasons people bought like early smartphones, early accessories, this is the reason why we have smartphone. Imagine it this way, like if nobody was there in the early days, hey, I'm not gonna buy something this expensive, that time we simply won't have engineers, researchers working again, and then boom, the technologies dies. Many technology have died like this. So this was also suffering from that. Then let's say you are a big person, let's say in case of India, you are Ambani and you have more than enough money to spare. You got that, you greased the palm, you paid under the table, you got the infrastructure, all that is awesome, but you have to worry about skilled labor needed. Now optical fiber slicing is not like copper splicing where you're like, okay, take the copper, weld it, solder it, done. It does not work that same way. It's very difficult and it's very tedious, because if any person is like, let's say they spliced it, that's a machine, you can do that. But let's say they spliced it but they bend it wrong, it will break there, the fiber will break, the connection will be destroyed. And if you have ring like architecture, every place you have to check now, every one of the connection you have to check whether this connection is working or not. And you have to understand, in case of let's say normal copper based connection, you have to worry about interference and bad connection. In this you have to worry about dust. Any port you have, basically you have to make sure the port is clean, otherwise even a single dust particle in the path of optical, it will flat out block the signal, flat out signal will not go. So there are a lot of problems regarding handling of fiber. So you need skilled workforce, and they are not cheap. They are really not cheap. So you have to find workforce that's not only good enough to, like, dig trenches or like mount on the poles, but you also have to find someone skilled enough to use splicers and expensive machinery and figure it out what's going wrong. That's the same like pilot. You don't want pilot in the plane. Plane is autopilot anyway. It's just when something goes wrong, you want to have pilot. Something like that is also true for optical fiber workers. You have to make sure that your worker can handle a bad situation. So these are the problems. That's why it's not everywhere. So this was my presentation on fiber to home, fiber to the home in some scenarios. I hope you liked it, learn from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.